Your Telegram bot works fine when you run it from your laptop. Then it stops the moment you close the lid or your Wi-Fi drops. A bot that lives on your personal machine isn't really hosted. It's just running until something interrupts it. To make a bot reliable, you put it on a small always-on server and wire it up properly. This walkthrough covers the token, polling versus Webhook, the service that keeps it alive, and what to do when the Telegram API itself is blocked in your region. I run managed Telegram hosting and proxy infrastructure on dedicated hardware in Singapore, so bots that need to stay up on real infrastructure are familiar territory. I'll keep this concrete and framework agnostic. The same steps apply whether your bot is written in Python, Node, or Go, because the parts that make it reliable live around the code, not inside it. Start at the source, the token. You create a bot by messaging botfather inside Telegram. You send /new bot, give it a name and the username ending in bot, and botfather hands you a token. That token looks like a number, then a colon, then a long string of letters and numbers. That token is the entire identity and password of your bot. Anyone who has it controls the bot completely, can read everything it receives and send anything as it. Treat it like a root password. Never paste it into a public repo. Never hard-code it into code you share. And if it ever leaks, go straight back to botfather, send /revoke, and get a fresh one. That's the single most important habit in bot hosting. Now the core architectural choice, polling versus Webhook. These are the two ways your bot receives messages from Telegram, and picking the right one is most of what hosting a bot well means. Polling means your bot constantly asks Telegram, anything new for me, anything new for me, in a loop. It's the default in most libraries, and it's the easiest to start with because it needs no public address and no certificate. Your bot just reaches out to Telegram. The downside is it has to run continuously and keep that loop alive. And if two copies of your bot poll at once, they fight. Polling is fine for a small bot on a server you control. Webhook means you tell Telegram, when something arrives, push it to my URL. Telegram then sends each update to your server as an HTTPS request, the instant it happens. No loop, no constant asking, lower latency, and it scales better. The cost is that you need a public HTTPS endpoint with a valid certificate, because Telegram refuses to deliver to anything but proper HTTPS. For a real always-on server, Webhook is the better design. For a quick bot behind no public address, polling is simpler. Let's set up a Webhook, since that's the proper hosted approach. You need your server reachable on HTTPS with a real certificate. The free ones from a standard certificate authority work fine. Then you tell Telegram where to push updates with a single API call. You call the API URL, which is https://api.telegram.org/bot. Then your token, then /set webhook, and you pass URL equals your public HTTPS endpoint. As a curl command, it's curl space the ap.telegram.org/bot, your token /set webhook, then -d, then URL equals https:// your domain / the path your bot listens on. Telegram replies with OK true if it accepted it. From that point, every message gets pushed to that URL. To confirm the bot is alive and the token is valid at any time, call getMe. That's curl, the same ap.telegram.org/bot, your token /getMe. It returns the bot's ID, name, and username. If getMe returns your bot, the token's good and the AP is reachable. It's the first thing to run when anything seems off. While you're talking to botfather, set the basics that make a bot feel finished. Send /set commands to give it a command menu so users see the / commands it supports. Send /set description and /set about text so the bot has a proper profile. And decide on privacy mode. By default, a bot in a group only sees messages that mention it or use a command, which is usually what you want. But if your bot needs to read everything in a group, you turn privacy mode off with /set privacy. Set this before you add the bot to groups, because the change only applies cleanly on a fresh join. Now the piece that turns a script into a hosted service, keeping it running. On a Linux server, you wrap your bot in a systemd service so it starts on boot, restarts if it crashes, and runs in the background without a terminal open. You create a unit file in destin/systemd, name it something like telegrambot.service. Inside, under the service section, you set exec start to the command that launches your bot. You set working directory to where the code lives. You set restart to always so it comes back after a crash. And you set restart sec to a few seconds so it doesn't hammer on a crash loop. Then you run symsysTR enable Telegram bot so it starts on boot. And symsysTR start Telegram bot to start it now. symsysTR status Telegram bot shows you whether it's healthy, and journal ctl-u Telegram bot shows the logs. That's the difference between a bot that runs and a bot that's hosted. It survives reboots, crashes, and you logging out. Keep the token out of the unit file and the code. Put it in an environment variable, either in the service unit as an environment line, or, better, in a separate environment file the service reads, with permissions locked down so only root can read it. That way, the secret lives in one protected place, not scattered through your code and your service definition. Now the part specific to this channel. What happens when the Telegram API itself is blocked? In some regions, api.telegram.org is unreachable, so your bot can't even talk to Telegram. Polling times out and webhooks never arrive. The fix is to route your bot's outbound API calls through a proxy. Most Telegram libraries accept a proxy setting. Usually you point the HTTP client at a SOCKS 5 or HTTPS proxy. At the HTTP layer, you can often set it with an environment variable. For example, exporting HTTPS proxy to your proxy URL before launching, and many libraries also take an explicit proxy parameter in their setup. A SOCKS 5 proxy on a clean IP outside the blocked region lets your bot reach the API normally. This is the same proxy concept as connecting the regular client applied to the bot's server-side traffic. If your bot runs on a server that's already outside the blocked region, you may not need this at all, which is itself a good reason to host the bot somewhere with open access to Telegram. Now the edge cases that trip people up. First and most common, the 409 conflict. If you call get updates by polling while a webhook is also set, or you run 2 copies of the bot at once, Telegram returns a 409 conflict because 2 things are trying to receive the same updates. The fix? Pick one. If you want polling, delete the webhook with a call to /delete webhook first. If you want webhook, make sure only one instance is set and no polling loop is running. You cannot have both. Second, webhook set but nothing arrives, usually the certificate. Telegram won't deliver to a self-signed or invalid certificate unless you explicitly upload the cert. Use a real certificate from a trusted authority and the problem disappears. You can check what Telegram thinks of your webhook by calling /getWebhookInfo, which returns the URL, whether it has a custom certificate, and crucially the last error message Telegram hit trying to reach you. That last error field is gold. It tells you exactly why delivery is failing. Third, the leaked token. If you ever committed the token to a public repo, assume it's compromised the moment it's public. Bots get scraped within minutes. Revoke it through botfather immediately and update your environment file. Don't try to clean Git history and hope, just revoke. Fourth, rate limits. If your bot sends a lot of messages fast, Telegram rate limits it and returns 429 with a retry after value. Respect that value. Wait the number of seconds it tells you, and don't hammer. A well-behaved bot backs off when told to. The rough limits to keep in mind: around 30 messages per second overall, and about 20 messages per minute into a single group. Design around those, rather than discovering them the hard way, when your bot goes quiet under load. Fifth, the webhook secret token. When you set a webhook, you can include a secret token that Telegram sends back in a header on every request. Your server checks that header and rejects anything that doesn't carry it. Without this, anyone who guesses your webhook URL could post fake updates to your bot. Set the secret when you call set webhook by passing the secret token parameter and verify the header on your end. It's a 2-minute addition that closes a real hole. Sixth, drop updates after downtime. If your bot is offline for a while on polling, Telegram holds updates for a limited window, then discards the oldest. When you come back, you may get a flood of queued messages, or you may have lost some. For anything where missing a message matters, webhook is safer because delivery is pushed as it happens, and you can pair it with your own acknowledgement so you know exactly what you processed. A quick honest note on scope. Hosting a bot well is about reliability, the token, the webhook, the service that never sleeps, and a clean route to the API. It is not about running many user accounts, which is a different problem with different requirements around device identity and IP. A bot is an official API citizen. It doesn't pretend to be a phone. So the word here is uptime and security, not disguise. If you'd rather your bot and the infrastructure around it just stay up without you owning the server, the certificates, and the proxy, that's the kind of thing we run. Manage Telegram hosting and proxy infrastructure on dedicated hardware in Singapore with clean routes to the API and uptime that's our job to maintain, not yours. Start at telegramvault.org and use code TGYT. For a hobby bot though, a $5 server with a systemd service is genuinely all it takes, and I'd rather you know how to do it yourself. A final reliability habit: monitor the bot so you know when it dies, instead of finding out from an angry user. The simplest version, have the bot, or a small separate script, send you a message if it hasn't processed anything in a while, or hit your getMe endpoint on a schedule and alert you if it stops returning your bot. System restarting the process handles crashes, but it can't tell you the API went unreachable or the Webhook certificate expired. A one-line health check that pings you on failure turns a silent multi-hour outage into a 30-second fix. In recap, get the token from BotFather and guard it like a password. Choose Webhook for a proper hosted bot, polling for a quick one, and never run both. Set the Webhook with Set Webhook, confirm with getMe and Get Webhook info. Wrap the bot in a systemd service with restart always so it survives reboots and crashes. Keep the token in a lockdown environment file. And if your region blocks the API, route the bot's calls through a clean SOCKS 5 proxy. If this helped, subscribe, because the next video breaks down mtproto versus SOCKS 5 for Telegram, which to use and exactly when. Thanks for watching.